Welcome, my friends. In this video, I'll be discussing section 3.2, which is titled Boxplots. Before we discuss boxplots, let's first discuss what is meant by the distribution of a variable. The distribution of a variable describes the possible values of the variable and how likely each value is to occur. For a quantitative variable, this is going to include four different things. First, we must identify the center of the distribution. This is typically done by finding either the mean or the median. Then we must describe the variability of the distribution. How varied are the values in the distribution? This is typically measured by finding the variance, standard deviation, IQR, and range. We'll be talking about the IQR and range in this video, and the standard deviation and variance in a future video. Then we must describe the shape of the distribution. There are a number of different terms that can be used to describe the shape, such as classifying the distribution as symmetric, skewed right, skewed left, unimodal, bimodal, or normal. We'll be discussing some of these terms in this video. Finally, we should identify any outliers if they are present. An outlier is just a value that's quite a bit different from the rest. So typically that's going to mean a value that's quite a bit larger or quite a bit smaller than the other numbers in the dataset. We discussed the mean and median elsewhere, and outliers are relatively self-explanatory. So before we introduce the boxplot, let's talk a little bit more about the variability of a distribution as well as the shape of a distribution. First, let's talk about the variability of the distribution. Two common ways to assess the variability or spread of the distribution are the range and interquartile range. Here's an example dataset that we used in previous videos. The 5-number summary is 25, 42.5, 57, 79, and 181. The range measures the distance from the maximum value to the minimum value and can be found by taking the maximum and subtracting the minimum. In our case, we can take 181 and subtract 25 to get 156. This tells us that the distance from the smallest value to the largest value is 156. We can also calculate the interquartile range, abbreviated as IQR, which is the range of the middle 50% of the data. This can be found by taking the third quartile, or the 75th percentile, and subtracting the first quartile, or 25th percentile. In our case, we can take 79 and subtract 42.5 to get 36.5. The middle half of our dataset spans 36.5 units. The IQR and range are both ways to measure the variability or spread within a dataset, but there's a more comprehensive way to measure variability, which is called the standard deviation. The standard deviation will be the topic of another video. Alright, now that we talked about the variability of a distribution, let's talk about the shape of a distribution. Now there's going to be a number of graphs here on the next couple slides, and for any of these graphs, you can think of the horizontal axis as being our quantitative variable, meaning further to the left would be a lower value of our variable, and further to the right would be a higher value of our variable. And then the vertical axis is representing frequency. So the higher points in the graph are representing more common observations. So these are all examples of symmetric distribution shapes. So in graph A, we have whatever the middle value is, you could view the median, is the most common value, and we are symmetric about that. This is sometimes what we call a normal distribution. Graph B is also symmetric, but this is what we would call a uniform distribution, where we have the same frequency across the entire graph. Graph C would be another symmetric distribution, but this would be considered bimodal because it has two peaks. Here are some examples of skewed right distribution shapes. In a skewed right distribution, you have a lot more smaller values of your variable and a lot less large values of your variable. And that can look like either graph A or graph B. Remember that the vertical axis is frequency and the horizontal axis is our quantitative variable. So lower values of the quantitative variable would fall towards the left, and we have a high frequency of those values. One way to remember that we have a skewed right distribution is as you move towards the right, the graph kind of diminishes or tails off. A good example of a right skewed variable would be income. There are a lot of individuals who have a relatively low income and not as many people who have a larger income, which makes that a skewed right variable. We also, of course, have skewed left distributions, which is just going to be the opposite of skewed right. we're going to have a lot of larger values of our variable and not as many smaller values. You can remember that it's skewed left because as you move towards the left, the graph diminishes or tails off. An example of a skewed left variable would be age at retirement. Most people are retiring at a relatively old age, but some people are able to retire a little bit earlier. Next, let's discuss the normal and bimodal distributions. These were mentioned on a previous slide, but they're so important that they deserve a slide of their own. The normal distribution is unimodal, which means it has one peak right in the middle. It's also a symmetric distribution, and right down the middle, you will find both the mean and the median. As you move farther and farther away from the mean or median, the frequencies get less and less likely. A bimodal distribution just means there are two peaks to the distribution. They don't necessarily have to be the same frequency for the two peaks, but nevertheless, there must be two peaks to a bimodal distribution. All right, now that we've talked about variability and shapes of distributions, we are ready to introduce the boxplot. A boxplot is really just a graphical display of the 5-number summary. So here's a data set that we've dealt with many times throughout the videos, and here's the 5-number summary for that data set. The minimum is 25, Q1 is 42.5, the median is 57, the third quartile is 79, and the maximum is 181. On a boxplot, you're going to have a number line that's going to need to span all of the numbers in your 5-number summary. Then you're going to draw a box. The beginning of the box should be your first quartile, in this case 42.5. The end of your box should be the third quartile, in this case 79. The median of 57 should go somewhere in the middle of the box as a vertical line. Finally, you will have what are called the whiskers in the box and whisker plot, which is another name for the box plot, which go up to the maximum of 181 or down to the minimum of 25. We'll talk a little bit more deeply about how to assess all 4 components of the distribution based on a box plot, but for now, just note that this box plot is showing a right-skewed shape. Remember that right-skewed or skewed right means you have a lot of smaller values of your variable and not as many larger values, and that's kind of what this distribution is showing. We have most of our values kind of clumped towards the bottom, and then we kind of skew off as we go towards the right. Now, a couple other things to kind of mention here. Between each of the kind of components of this graph is 25% of the data. So between the minimum and Q1, there should be 25% of the values in your distribution. Between Q1 and the median is also another 25%. Between the median and Q3 is another 25%, and finally, between Q3 and the maximum is another 25%. That means that the length of the box is actually 50%, which is represented by the IQR. You may remember that the IQR is Q3 minus Q1, which is the length of the box in the box and whisker plot. So really, that's all the IQR is. The IQR is the length of the box in the box and whisker plot, which represents the middle 50% of the data. Now, when I was taught the box plot, or box and whisker plot, those two terms are used interchangeably, this is the version that I was taught. But there is an alternative form of the box plot, or box and whisker plot, which is going to indicate the outliers with dots. And that's going to look something like this. So now the whiskers don't necessarily extend all the way to the minimum and the maximum. If there are outliers, which are values that are quite a bit smaller or larger than your typical value in your dataset, those are going to be indicated by dots. Now, in this distribution, this is looking a little bit more left skewed or skewed left. We have most of our values kind of clumped towards the right hand of the distribution, and then we have a tail toward the left. So this could be described as a skewed left or left skewed distribution. Now let me mention that in general, a box plot is pretty good at showing the center, the variability, and the outliers if we're showing this version of a box plot, but it's not quite as good at showing the shape of the distribution. Especially if we have a bimodal distribution or a uniform distribution or a normal distribution, it's not very good at kind of differentiating between a number of those different shapes. We can kind of indicate to some degree if it is skewed, but some of the specifics of the distribution shape can't really be shown by a box and whisker plot. Instead, we might want to use what is called a histogram, which will be the focus of a different video. All right, so here's another example of a box plot or a box and whisker plot, and we're going to discuss all 4 components of the distribution of a quantitative variable. So first, we can assess the center by looking at the median of the box plot. We can't really tell the mean, but we can tell the median, which is the line down the middle of the box plot. In this case, we could say the center, or the median, is at approximately 101. The variability can be assessed based on a box plot either by the range, which is the maximum minus the minimum, or by the IQR, which is Q3 minus Q1. In this case, the IQR is about 13, so that's the range of the middle half of our data set. And then the range is 46, which is the difference between the max and the min. The shape is roughly symmetric in this case. We are not able to tell if the distribution is unimodal, bimodal, or normal based on the box plot, but it doesn't seem to have any significant skewness. It's kind of a symmetric type shape. There do not appear to be any outliers based on this box plot, assuming this is the version of the box plot that would identify the outliers with dots. And even further from that, we can tell that the min and the max are not really that far away from the middle of the box, so we can kind of conclude there doesn't really appear to be any outliers based on this box plot. All right, here's another box plot for you to try. So see if you can answer these 5 different questions based on this box plot. All right, that's all I had to talk about in this video, so I will see you in the next one.